Okay. See, first we'll see the use case. So our ultimate aim is we need to run our application. Okay. It can be any kind of application, maybe some Java application or maybe Python or Node.js, .NET, whatever it is, right? So in traditional model, how it will be? So take an application part basically. Okay. So if you take an application, earlier what is happening? The same application we used to run on the servers. Okay. Servers will be using there and will be running, and it used to take some days. Okay. It used to take some days. Why? Because you need to create server, install, configure, deploy application and run. Ultimately, our application we need to run. This is main agenda. Later on, virtualization came. Virtual machine. Here, our effort is somewhat reduced. From days to it will become as hours. Maybe within 1 or 2 hours, we may create a virtual machine and deploy the application. Later on, instances came. Cloud instances. Now, which we are using AWS, EC2 and all. So the time is reduced to some minutes. Okay. So this is what the trend from the beginning to till now. Traditional model, we have some days it used to take servers, then virtual machines, now the cloud servers. Upcoming trend or going trend is running with the containers. We used to create a container. Container is nothing but an isolated environment or an abstraction layer on your OS can create and run our application. This can start within a seconds. A container can able to start in a second. That is what our containerization can able to help you. So using this containerization, we can able to achieve a faster deployments. Simple example I'll tell you. So take a microservices deployment. Microservice, micro means small. Okay. You are using bank account, many internet banking. Will use a. So when you use internet banking, what you'll do generally, you'll be login and you'll enter your credentials. Then you'll go to login page and you may do multiple operations. Like you can check your savings account balance, you can check some credit card payment, you can check do some transfer, or maybe you can do some DMAT or some FD, various things you can do. So if I log in, for example, I have various things. This is a simple application, I log in. Okay, assuming that this is also one application, right? It is back and running in one server. Okay, now we'll compare traditional model and the microservices model, how it is. So traditional model, what happened is I have a server I'm buying and I kept with all the configuration. I installed this, for example, this Axis Bank maybe. This application I deployed in my server. Assuming that all of you guys, you have accounts. Okay. So first user, when he logged in, connected to the server, login, checking the bank statement, savings. Second user logged in, she logged in, then went to the credit card, checking the credit card payment. Third user logged in, login function is happened. Then after that, doing some trading, maybe she's doing some DMAT. Now, first user, when he logged in, checking the balance also, my application is responded. Second user, credit card payment, my application is responded. Third user, when she logged in and doing that DMAT account also, my application is accessed. Okay. Now what is happening? Different users are accessed and they may be able to access their service. But for all these users, my application is responded. Whether it is a simple balance inquiry or bigger trading account or maybe credit card payment, entire my application is responded. It's a monolithic single application. Okay. Now I thought to do in a different way. It's called microservices model. Okay, so how to do that? So in the microservices model, now I'm creating the 5 containers. Okay, my application, I'm creating 5 containers. In 5 ways I want to divide. The first container is login container. Second container is saving related. Third container related to credit. Fourth one related to some demand. Fifth one related to some FD. So different features of my application, I made it say 5 different types of containers. The ideal principle of the container, it can able to start in a second. If you send a request, it will start faster. Okay. Just a minute, guys. There's some script where we are migrating Git to GitHub migration. We discussed Git, right? So we have a bare Git repository that now we have a shutdown period. No one will has a commit. Today morning I communicated. Okay, so in that we don't want to allow anyone to push further commits. At the same time, we want to migrate to the GitHub. That was the plan. So for that, one my manager was thinking. Okay, fine then. So uh, we have now same monolithic application. Earlier, that is the working model. So now what I planned is, so now I have 5 containers. So ideal function of um, the ideal function is that we need to replicate that microservice model. Container has to start. So what I did is, so let's see that all these containers, for example, I have 5 containers. For example, user 1 logged in. User 1 logged in, what is the functionality majorly? He has to check the savings account balance. Now out of 5 containers, for him first container is responded, login function, done. And Out of 4 containers, second container will respond because he has to check the only transfer. Remaining 3 containers no need to respond for him because not necessary at all. Very clear. The operation is very clear. Then second user when login, again login function has to respond. And some credit. No need of the remaining 3 containers. 1 and 3 will respond. Remaining 3 containers no need to respond. So we are very clear about our operation in the microservices architecture. What is the advantage? Now your service will be faster. Enter monolithic application, no need to respond. Now single service can able to respond for your query. If something happened wrong, I no need to debug entire application. Only that particular container related service I can debug. It makes our life easy. That's what we can able to do it. Okay. Okay, so like that we can able to maintain our microservices architecture and makes our life easy. That is what now the current trend is going on, microservices architecture. Last month one guy got offer letter, you remember Axis Bank. One guy got offer letter. In Axis Bank he got offer letter. He's specifically working on this one only. Same model. Because they have a Kubernetes architecture to run their application. So it's easy to maintain. Instead of maintaining the monolithic application and all those things, the container level architecture will makes more better. That's what they'll do it basically. Okay. So now what is a containerization? Containerization is a process of creating an abstraction layer on your OS and can create your containers. In intro, they'll ask you, when you say that I know containers, what is the difference between the virtualization versus containerization? So virtualization means what? You can see the difference. Virtualization, what happened is we have a hardware. On top of that, we are installing hypervisor. On top of that one, we are creating a one guest OS in your virtual machine and running your application. You see. So if you take a virtualization, we have a hypervisor. Maybe your VMware workstation, VirtualBox, Hyper-V, Zen, ESXi, whatever it is. On top of this hypervisor, we are creating a one virtual machine. Each virtual machine has its own guest operating system and your application you will be installing and running. Got it? Now coming to the containerization. So on the OS level, we are installing one container engine. Here we are enabling the containerization technology, one container engine, simple package it is. It can be Docker, can be Core, what is that, RKT or Mesos, whatever it is, different part. By using this container engine, we are creating a container. Observe the difference between the container and the virtual machine. Virtual machine is running with the guest OS and binaries and application. Whereas container doesn't have guest OS. Because of this one, your containers are starting in a second. It's like a one process. Reboot your laptop. How much time it will take? Reboot, for example, after using more days. It may take some time rebooting because it has to boot. Now, assuming that server side you need to reboot, how much time it will take? In my company, by mistake, if I do reboot my server, it will take 40 minutes. I have to wait 40 minutes, no doubt at all. It will take 40 minutes straight away. Because it's has a lot of process has to be boot from the MBR records. Okay, it's not a simple thing. Now, your containers doesn't have any guest operating system, means that boot time is no more. Straight away, your containers are running using host binaries and app 1. Just a minute, guys. You bought our laptop, charger, give me charger. Thank you. Yeah, please.
So you're migrating all where repo.
Right.
What about the users?
Users, we are giving, see, GitHub is a domain controller,
Yeah.
my HV domain controller. So we are adding the user separately by creating user group there. That is what the LDAP, it is connected with my LDAP. So via that one, we are managing it. Change to uppercase. Just I want to do some dummy commit. Here, anyway, this is locked. I have to give explicitly the my Zira ID. Otherwise, it will not take at any cost. This is the regular mechanism. Yes, that user editions and all those things we need to do. So how we did is we have a enterprise GitHub. So there we have a control on this LDAP control and users and all those things. Okay, so via that one we'll be controlling it. Otherwise, yes, there will give the
in bare repository they are using it LDAP only or
yes. In my company LDAP, it is interlinked. There we need to change the roles. Who has the read permission, write permission, all those things. We have some control. He is a section manager. Means manager 1, manager 2, manager 3 is the section manager. He is almost now around some 50 plus, 55 something. Okay, still doing technical work. Pure Java guy. He is my manager. Okay, let's find. Okay, so in interview, they'll ask you this part about that virtualization and containerization difference. That time you need to explain this one clearly. The major difference is there is no guest OS in the container. Okay, tell me what do you mean by container in general? We'll use at home, right? Container. You are using right anytime went to kitchen. So container, huh? There we have various containers, right? Why we have to use the container there?
Separate the things.
So we have to mix salt and sugar together. We have to make it separately. Why? Why we have to?
We need sugar, so we take sugar. That's all.
So it's very simple. Your requirement is very clear that yes, your whatever the quantity you have, that item you have to separate in an independent item and you have to store. So I have for example, container contains the sugar, container contains the salt. Is a separate. Both should not mix. Otherwise, it become ORS, no? Correct? So both are independent. Same place, both are independent, both are isolated. And container will give you protection to keep that specific product in a secured way. Any ant should not, any air should not expose. This is what your container is giving. This is what daily you are doing, right? Same thing apply here. There is no difference, okay. Okay, so we are talking about container, right? Sorry, I was disconnected so much today. Okay, so generally that containers basically it's giving now. Same way here, the quantity we are taking as our application. Example, you see here, see that I have container 1, container 2, container 3, container 4. I have 4 containers on the common host. So we have a Linux operating system. Let's compare containers basically on Linux only. Okay, containerization basically came from Linux. We'll see the Windows support later in the Docker part. By default, your containerization works on Linux. On top of Linux operating system, I install some container engine, maybe Docker. Why only Docker? Means it is a popular, so we are talking easy. That is the reason. About Docker engine, we created some container. Container is an abstraction layer and it is a lightweight. Container 1 I'm running with a specific application, container 2 running with some specific application. Both are running on the same host, but both containers will not mix, application will not collide, both are running independently. That is what your container space will give you. It's an isolated space. Each container is running its own isolated space and managing it. Okay, so using this one we can able to maintain our cluster. I mean, maybe the single container, then later we can deploy our application. Now here your containers are running faster, lightweight. How? What makes the difference here? So in containerization, we have two important components. One is image and other one is the container. Two important things. Keep in mind that image building is important. It is hard for our containerization throughout our life. You are using containerization, that image building is the main thing. Container creation will change when we discuss Docker, when we discuss in Docker Swarm, when we discuss Kubernetes. Okay, image building is constant, mandatory. They'll ask you in interview, and you have to do it in your regular day-to-day life when you say that you know containerization. Keep that in mind. Okay. So image is nothing but a static file contains of your OS, binaries, and your application. Container is a runtime environment of your image. Simple thing. You bought a new laptop. After buying, what you will do generally? You'll install your operating system, right? Without laptop, by using that ISO file, will you able to access your OS? Will you able to see that graphical view and all those things? But everything is there in that small ISO file, that 1 GB ISO file. Once you install inside this laptop or the machine, it will be installed and it will run. We can see that runtime environment. Clear? So ISO file is nothing but your image. A static file contains of your operating system that you are buying with some money, maybe Microsoft. Linux is free. Using that one, you are installing in your laptop or server, VM, wherever it is. Then it is running. It's a runtime environment. Then we can start the server. We can log into the server. We can execute some instructions. That is what it will happen. So your machine is a runtime environment of your ISO file. Similar way, here we have an image and container. Image is nothing but your static file contains of your OS application and its binaries. Container is a runtime environment of your application, nothing but your image. So your containers are lightweight. Example, maybe you're creating a virtual machine with CentOS. You have to download the ISO file, right? What is the minimum size you will be downloading there? Maybe some 1 GB approximately. But same thing here, that image will get hardly some 100 or 200 MB. Your images are lightweight. That is a key principle to build the image. How much lightweight you are building, that much efficient it is. Using that image, we can able to run the container. Okay. So using that one, we can able to create our containers and we'll be running that. Your containers are lightweight. Okay. Using that one, we can able to make our runtime environment faster. Okay. How it will become lightweight? Your containers are running with our host binaries and its shared kernel. That is what we'll do that basically. Example, you take that container one is there. Container one, it is comes with a very lightweight image, 100 MB CentOS image. Then your container one utilizing your host binaries and host shared kernel. All kernel is same Linux. The kernel is almost same. Any Linux you take it, no much difference. File system level, some difference is there. That's it. So your containers doesn't have any guest operating system. It using your host shared kernel and it will run. Because of that one, it will become lightweight. Okay, that is what it will do basically. Okay. This is what the mechanism it will do basically. Okay, your containers are lightweight because there is no guest operating system. By using the host kernel and the shared host binaries, will be running it. That is what we do. Yes. Okay. So basically, that is what it will happen. And to achieve this containerization, we'll be using this Docker concept. Okay. So containerization basically work in our what is that container Linux operating system. It will work, no doubt at all. But Windows, your regular containerization will not work. For that purpose, we have a Docker. So what Docker is giving? Docker is developed basically on the our containerization only, nothing but containerd, and it will be running. Okay, and using this Docker, we can able to install either in your Linux or Windows or Mac, and we can able to install either community edition or enterprise edition. Community edition absolutely free. Even for our practice purpose, we are using it. Enterprise edition, it's a license. We have to take a license. Why license means there we have a support for our image building and some security updates, troubleshooting. That support will get it. For that one money. Production case that is required. Otherwise both are same. There is no much difference. Next thing is Docker has its own cloud account called Docker Hub. How we have GitHub? Similar like we have a Docker Hub. GitHub we are storing the code. Docker Hub we are storing the image, container images. Okay, so this is what our containerization will work internally. Now I'll show you simple thing how to install the Docker, how to set up and how to do that part. See that basically containerization will not work on the Windows. Docker is giving the flexibility to install it. So you can install either Mac, Windows or Linux. Okay, then you can able to run your application. All those things can be done. Okay, so now I'm creating a simple server. We'll see the Docker installation and getting the image and creating a container. I'll show you. Next class we'll be discussing in detail about how to build the image. That is the important part. Okay, let's see. So let me log into cloud account. So I need one Linux server I'm taking. I don't want to install anything on the Windows. Windows, it will consume more space. In Windows, how it will work, you know? So basically, in our operating system, we are installing container engine directly and will run the containers. Na? But in Windows, how it will happen means on top of the operating system, it will create one hypervisor here. Then on top of the hypervisor, it will create one VM. On top of that one, Docker engine will come. Then it will run the containers. Extra 2 layers will be coming there. Okay, fine then. Let's create a server. So I'm taking Linux server. Then keep your login. Okay, here I'm choosing my existing security group. You no need to open any special security groups now as of now. Okay, open SSH protocol only. But I'll tell you, we have to open some extra ports if you want to expose your application outside. By default, what happened? Your application is within our node only because your container is a private space. It will not expose outside. If you want to expose outside, we need to expose the port number. For that one, we need to open some extra ports. We'll see that one later. But in my security group, I already opened a port 9000 to 9010 I opened. Okay, I already opened. That is the reason always I'll use this security group. I don't want to change again and again, so I'm using same group again. Remaining all are as it is, and let's launch instance. Okay, it's running. Let's connect the server. Okay, let's see. So enter the Docker. Why Docker means Docker is easy. The way you are using your Docker commands and all, it is easier thing. That is the reason we'll be using the Docker. So to install this Docker, you can install either Windows, Linux or Mac. Linux also supports with all flavors. So this is Amazon Linux Docker repository already there. Simply run minstall Docker. 99% it will be installed. So Docker we are installing 20.10 version, latest version. Proceed. Here my company, it will not work like this. Yes, I took initially 2 days to install and pull one image from Docker Hub. 2 days. I don't know that time. Lot of things are there to troubleshoot all those things. Okay, now it is installed very fast. Okay, so let's start the service Docker start. Okay, done. So Docker is running, right? Yes, as I said, we have two important components. One is image and other one is the container. Without image, there is no container. And you can't run single container with multiple images. Multiple containers can run by using single image. Clear? You have a single ISO file. You can install in multiple laptops, right? But in single laptop, ideally, we can't run the multiple OSs, ideal case. Maybe you do dual booting, that is a different part, ideally, right? Same thing, your containers are running with a specific image. Single container can run with any of the one image. Same image, I can create a number of containers, no doubt. Okay, first thing is verify. So if you are familiar with Linux commands, now Docker commands is easy. Okay, what is the ls command? List of directories. List of everything. Process also list. What is ls command? Listing. After listing is the important part. What is listing?
Directories, files and links.
Proper way. ls means list of
Both directories and files.
directory contents. Simple. Okay. So now Docker. First we'll verify the version. Okay. Officially with whom we have to start. 20.10. Okay. So version is fine. Now verify the Docker image ls. List of images. No image is there. Just now I got the container. No? So no image. Docker just now we installed. So no image. Fine. Accepted. Next one is Docker container ls. No container. No image means no container. No chance at all. ls -a. List of ls-a means here no hidden file. -a gives the stopped containers or exited containers. ls means running containers it will give. Okay. So you can create an account hub.docker.com. So using that one you can manage. So here already I have an account. You can sign up. Maybe with your Google account you can sign up. So I already have an account. What is the mail I got? Okay, here see, these all are the images I built. Okay, we'll see that image building, pulling and all those things later. Maybe, for example, now I'll pull simple CentOS image. See that CentOS officially they built an image and available. Okay, this image we can able to pull locally. Again, pull and push mechanism, same way. Earlier we did git pull for pulling the code. Now we are pulling the image. Okay, fine then. Let's come back to our container. So Docker image pull. What is the image I want to pull? CentOS :7 means 7 version I'm pulling it. CentOS is the image name. :7 is called tag nothing but representing the version like CentOS 7, CentOS 8, all those things. I'm pulling the 7. So it's download, it will download faster. Cloud server, na? It will be faster. Fine. Again, you verify the Docker image ls. See that the size is 200 MB. CentOS size is 200 MB, which was built 15 months back. Long, it's a very long period. Okay, this is one thing. Now let's say I'm pulling another image pull called Alpine. Alpine is a one operating system. It's very lightweight, faster. For containers, this is the recommended thing. Download it. Verify image size. How much? 7 MB. 7 MB is one image. You can create container, you can run the Linux operating system. Yes, you can do that much lightweight. Okay, anyway, you don't know Alpine, ignore the Alpine, not a problem. Let's continue with the CentOS. At least we know Linux commands. We discussed 1 or 2 commands now. That will execute at least, right? So now how to create a container? So Docker container, create you can use or run you can use it. Create means it will just create but it will not run. Run means create and it will run. So Docker container run space -it. What is IT? I for interactive, T for TTY mode. We'll get a container interactive session, we'll get it. Followed with, I'm giving the name of the container is C1. Anything, you can give your name also, not a problem. Then image CentOS :7. That image already we pulled. And give the command with what command you want to log into the container, interactive. Na? So I'm giving bin bash. I'll get a bash prompt. My container created, I'm inside the container. You see, this is my inside my container I logged in. 073 is my container ID, is nothing but my host name. Okay. Verify the OS version. Na? How to verify OS version? I said that this is CentOS 7 image, right? So I created container runtime now. So it must be shows the CentOS version only. How to verify the OS version? Sorry?
ETC OS release.
ETC OS release.
ETC OS.
Fine. Saved somehow. Showing na CentOS 7. Clear? Now I can do whatever I used to do earlier. I can do everything now. I can run the commands. I can install any software. I can run all the applications. Everything can be done. All our Linux commands you can run. Git you can install. Jenkins you can install. Everything can be done. Clear? So how to come out of the container? Control PQ. I came to host. My container is running. Docker container ls. I don't want container. rm -f removing forcefully container name C1. No more container, you can verify. Clear? Any doubt? Ignore the image part as of now because we'll discuss separately image building, that I'll separately will discuss by writing the Docker script and all. Assuming that image is available, we created a container and running. Clear? Okay, now I'll host application. Same command I'm using, but this time I'm passing one more thing called -p. P for port publishing. You remembered I told your container is a private environment, na? Assuming that container one some application is running. How to access this application outside of the box? Means outside of your server. We can't access this container directly. See, assuming that I'm somewhere outside I'm there, I'm reaching up to server level, but I can't reach this container level. For that purpose, assuming that container one is running with the port number 80, then This port number 80, I forward with the host port number, for example, some other port. I'll take now 9000 port. Then via host 9000 port, I can reach to the container port number 80, called port forwarding, port publishing. Then I can reach the container one port number. Okay, let's see. So I'm giving port. First thing is the host port, colon 80. Next is container port. My Apache server running port number is 80 by default. HTTP port number is 80, right? If I install Apache server inside the container, it will run with port number 80, accessible via port 80. Na? So I did port number 80, I'm forwarding to host number port number 9001. Clear? Any confusion here? Port publishing. So container port number I'm forwarding to the host port number 9001. Let's create and run the application. You can understand maybe. Again, everything is running same. Okay. Now inside this container, nothing is running. ps-ef. Nothing is running. Now I'm installing Apache server and I'll host application also. Let's see. So yum install httpd-y and I'll do service command won't run. Let it install first. We'll see one by one. This is already known thing for you, right? We did multiple times. Okay. Clear? Now we need to start service. Na? Service httpd start. This will not work. What it's saying, service command not found. They removed the unnecessary things. It's extra package they removed to make your image lightweight. So what you can do here is you can start via system binaries. Apache server is running now. Now open this IP address in the browser. Port number you have to give 9001. Then it will reach container 1. Got it? Huh? Maybe I'll create simple application inside the container 1. Let's see. So inside container Apache server, na www.html, I'll create some simple message echo. I'll say this is container C1 with host name. Host name. Right, this message I'll send to index.html. Okay, some HTML tag also will add. Okay, now refresh. Sorry. Clear? Any doubt? Let me replicate again same thing with container 2. Okay, with the host number container C2. Everything's same. Let's come out of the container. Control PQ. So we created container C1. Now I'm creating container C2. Port number 9002. Okay, I can't use same port number. We'll get a conflict. Same thing I did. Okay, so I'll be running the same command. Okay, I'll run the same command. Copy this. Okay, so I'll do yum install httpd-y. Okay, var www.html paste. So it's not C1, it's a C2. Okay. Fine. So let's see If I refresh 9001, I'm getting container 1 application. If I give 9002, I'll get a not coming.
Start there, purchase.
Here I not started, right. So let's start user has been HTTPD. Okay, done. Let's refresh. If I give 1, it is coming this one. If I give 2, same thing. Same host, 2 containers, 2 different applications are running. Clear or any confusion? Why I use 9001 port? Because I can reach up to server level, but I can't reach container directly. It is in a private space. To reach that one, I did the port forwarding of my application. Then via that 9002 port is equal to my container to port number 80. I can reach up to host level, I have access, not container level. For that convenient, I port forwarding I did. In my security groups, I showed now Linux security group. I opened 9000 to 9010 already opened ports. That is the reason it is accessible. Otherwise not. Okay. So using this one, we can able to access. Like I have my own image. Let's come out of the container. See that now I'll create a different container called C3 and port number 9003. Not CentOS. I'll give my own image which I built. Wrong name I gave. Oh, I gave wrong. It's not this one. I have to give server identifiers. But again, it will give error saying that C3 already existed. It will give error saying that C3 is already existed. Maybe. Done. Okay. Now let's see 9003 port number. So whenever it will create, it will give that particular timestamp and a container name as host name, or it will come that host IP address, nothing but container IP address. That is what that script. Okay.
Container is running with same name, so C3.
You see, na 885. Yeah, it's running with C3. This is the host name.
Yes.
Container name is different. This is the host name. Host name is running this one. Enter host name, na host name. C3 is the container name I gave.
C123.
Okay, it's equal to your container ID. Container ID is nothing but your host name. Clear any confusion? So first thing is containerization concept is clear or not? Very simple. Earlier what is happening? We have a virtual environment. Compare with virtual. There we have a dedicated virtual machine with guest operating system and application. And when you create a virtual machine, you observe, you will give the RAM, 1 GB RAM, 1 CPU, certain GB of storage. Now, when you create a container one, you will not give all those things. How then it will work? Assuming that if you see that architecture, container 1, 2, 3, 4 is there. I have 16 GB RAM, right? So 16 GB RAM, assuming that container 1, 2, 3, 4, when it starts, it will take minimum of 1 GB, 1 GB, 1 GB. Assume minimum. It will not take that much. 64 MB it will take. Assuming that it's consumed 1 GB, 1 GB, 1 GB. Remaining I have 12 GB RAM, right? Container 1 application accessed by many users. It requires more resources. Then what happens is container 1 application will take the more resources from the host itself. So it will increase 1 GB to 2 GB, 2 GB to 4 GB, 4 GB to 8 GB. Maximum it can reach. It is a dynamic allocation. Unlimited. It can go up to what extent? My host limit. Maybe host reached 100%. Still container expecting more resources. Container will go to exit state. The capacity it is expecting beyond the capacity. So it will exit. Clear? It's a dynamic resources allocation. But virtualization, the VM is fixed. If you want to allocate more resources, you need a downtime until unless it's not in an orchestrator model. Got it? This is the major difference. And why your containers are faster? It is running on your OS itself. There is no boot time environment that is removed. Your container is equal to one process. It's equal to one process on your host level. And your containers running faster because your image is already built, ready-made with a certain configuration image, whatever it is we built. Using that one, it will be running. And it is using your existing host kernel and binaries, and it will start the process. So it will not take much time to start the process. That is what your containerization can able to give you. Clear? So we have pros and cons every time, everywhere. When you say that something is good, definitely there will be bad. This is a universal principle for anything, anyone, anywhere. Take it anywhere. There is no perfect concept that you remove it. Okay. You can find the best out of all. You can find best person. You can find best mark. You can find some best place. That's it. There is no perfect concept. So here, your containers are running faster. Deploying application faster, everything faster. Now take a negative place. Container removed. So I have now how many containers are running? Docker container ls. So I have three containers C1, C2, C3, right? So I'll do rm-f C1, C2, C3. All are removed. Whatever I did, whatever I installed, whatever application I did, everything gone. Okay, I have a sense I did with my sense I removed. Assuming that this happened accidentally. Container removed without your knowledge. In the midnight you slept, it removed. Something happened. Then how fast it is created, that much fast your data will removed. What is the use? See, server is good, but no backup, no storage. Then what is the use? In my company, same thing. Yesterday when I had a meeting with my manager, I was telling, I have a ESXi with a 256 GB RAM. It's a G9 server, high-end mission, but no storage. I can't use that compute capacity. It's a useless. So now your container started fast, running faster, everything is faster. But when it is removed, there is no data persistence. This is a drawback. To achieve this one, we'll be going to use the volumes concept. Okay, we have a separate class for that one. We'll discuss separately about the volumes. Okay, so today we'll be looking for that one, how to set up your Docker. Don't try in Windows, try in Linux machines, EC2. It is faster. And how to get any image, you pull any image, no charge. Create containers, left and right you do. Okay, let me send you the documents.
Can we create Dockers on the, that microservices which we created in VM?
VM?
Hello.
Yes, which VM?
Like in Kubernetes, we have created one microservice on the laptop now where we used to do the practice. So can we create this Docker on that thing?
Which one you're talking about? The playground servers, huh?
Not playground. This is micro Kubernetes we have installed, na?
Yeah, you do it. Okay. Anywhere you can do, wherever Linux is there, that you can do that. Okay.
Okay. In a real life scenario, so this servers are used or that servers are used for Docker purpose?
Your Linux servers are used.
Linux.
That is the main. Okay. So it can be any runtime environment, mostly Linux runtime environment.
What was the question he asked?
Okay, we not discussed, we attended other classes, na Kubernetes, micro Kubernetes, there we can use or not, his question is, ignore it. Okay, we'll see in the Kubernetes anyway, that concept. Okay. Yeah.
We are currently using on Linux. We are using Docker. Can we directly use on hardware like hypervisor?
No. That is what I said. What is a containerization? Containerization is it's a abstraction layer on your operating system and provision to create a containers. It's not hypervisor. We need at least that Linux kernel we need. At least to run the container D. That is the main technology for the containerization.
We can say containerization main dependency is Linux.
That is what the OS layer abstraction layer of your operating system. That is what the containerization. Okay. Any minimal Linux operating system required, then you can run your container engine. It can be Docker or anything, or CRI-O, or maybe your Podman, can be any stuff. Okay. Otherwise, no. That is the main difference. Virtualization directly can make the things on the hardware, but here no, it will not.
So when we install this Docker on the Windows, we will be getting this Linux terminal itself, right, to operate on it.
From your command, you can run. I'll show you maybe how that architecture.
You get an interface of Docker itself, and also you can.
Interface means you open our command prompt and run the Docker commands.
Both things will work.
But how it will work, Docker.
That will separate Docker interface.
I'll tell you that architecture, how it will be. Images.
That interface is somewhat buggy than last time.
This one. Okay, open this. How in Windows this will work? See, we have an operating system. Which one? Windows operating system. On Windows operating system, generally you have your regular OS functionalities and all those things. On top of this one, we'll be creating, how this will work is, here we have a Hyper-V, and it will create this host compute service. This will create. On top of that one, will be installing the container engine. Container engine running with our Docker Linux. Then on top of that one, you can run your Docker commands and all. Maybe if you see much more in detail architecture, see this guy is compared between the Linux and Windows. Okay, see that Linux we saw, OS we installed, and we installed our container engine, and on top of that one we are running all the commands. But here what happened is your compute service will install the Hyper-V. That is not there. Just a minute. Hyper-V should be there. This is the architecture. You can see. This is what the model. Okay, see that what happened. You have Windows Server. Okay, here on top of Windows Server, it will create a one Hyper-V VM. What that VM? It is running with your Linux kernel, nothing but Docker Linux. It will create. That is Docker giving this architecture flexibility on the Windows. It is running with your basic binaries of Linux. Because of this one, you can run your container engine and you can create multiple containers. This is the architecture they'll model. Directly it will not work. Docker gave that flexibility. Regular container engine, no. It will be looking for the Linux kernel. Docker gave this kind of provision, and you can run the containers in your Windows. You can run regular commands. Once this setup is on, you can run, open your Windows command prompt, run Docker container ls, Docker image ls, all you can run. Regular command, there is no difference. But backend architecture is different. This is provided by the Docker. And here you can assume that one, same running these two containers in Linux, it will consume, for example, 2 GB RAM, assume. But in Windows, it will consume 4 GB. Why? Basic this Hyper-V VM itself, it will take 2 GB RAM minimum. By default, straight away it will take. So it's some complicated architecture. Got it? Fine. So then tomorrow we'll continue with the image building. Okay, that is important. Image building. Then after that, that pulling and pushing to the Docker Hub, create a Docker Hub account also. Okay. So if you're not able to understand anything, let me know. I'll explain again the container concept. No doubt at all. Because this is fundamental, you must learn. If you're not able to clear anything here, further concepts will be problem. Kubernetes will be bigger problem. Try to get a hands on this one and install it and run, create containers left and right. You do. There is no harm at all, no charges at all. Okay. Do any application deployment. Not a problem. Okay. This one will integrate with our pipeline. So once you commit the code in the Git, automatically pipeline will be triggered, then container image building will happen, container will create, push into the registry, everything can be done automatically. That entire pipeline we can build. Clear?